Okay, bloggers, here we go. First of all, the good news, I think I can keep this to under 5 minutes, so let's get going. Okay, so today in class you were playing around with discrete random variables and probability distribution. So first of all, a little word about discrete. Discrete is something you can count, whereas continuous is something that you can measure. Okay, so that's what we talked about at the beginning of class. Discrete versus continuous. So when we're doing these probability distributions, we're only talking about discrete data, so we're talking about things we can count. So a lot of our examples are going to have to do with dice and flipping coins, stuff like that, because you can actually count the outcomes. You can see what happens. You're not measuring the outcomes, you're counting the outcomes. So discrete is things that you can count. So there's a lot of math notation here, so let's just go over this. So if x, notice that's a capital letter X, is a discrete random variable. Okay, so we're talking about a certain type of event, and its sample space is given by lowercase x. So notice this is uppercase. That's basically what type of thing is happening. And then the lowercase ones are all the different values of that thing that's happening. So for example, if you roll a die, the probability that you are rolling a die, we're talking about that's the sample space is going to be made up of the values of rolling a die, and those values are going to be the lowercase x's. Okay, so the capital X is the rolling the die, the lowercase x are all the different answers you could get, all the different outcomes you could get when rolling the die. All right, and it has matching probabilities. So our probabilities, so if say the outcome here is you get a 1 when you roll the die, what's the probability of rolling a 1? Okay, say the second x is you roll a 2, then this p sub 2 would be the probability of rolling that 2. Okay, it could also be, you know, flipping a coin, heads or tails, except we need to be able to describe the x in terms of a number. So when you're making your table, x's have to be numbers. So you can't say x1 is heads and x2 is tails. Instead, you have to figure out a way to describe the variable so that you can use a number. So for example, if I flip 2 coins, the number of heads that I get. So then your outcomes could be, well, I could get 0 heads, I could get 1 heads, or I could get 2 heads if I'm flipping 2 coins. Okay, so these x values here, the sample space, you always have to be able to write them in terms of a number. All right, and the probability, of course, will always be written as a number. All right, so what does this say? The probability of any given term, okay, whether it's our first, second, third, fourth, of any of our given values has to be between 0 and 1. Okay, that's what this is saying. The probability for any given event has to be between 0 and 1, and it could be 0 or it could be 1, but it can't be any bigger than 1 and it can't be negative. Okay, so what does this mean? This means the probability for each event must be between 0 and 1 inclusively. Sorry, a little misspelling there. So that means it could, when I say inclusively, it means it includes the 0 and the 1. So the probability of an event could be 0, that means it can't happen. Or it could be 1, which means that it's definitely going to happen, or it could be somewhere in between. So when you're calculating your probabilities, these numbers over here, they have to be between 0 and 1. And that also includes 0 and 1. Notice the little equal sign. So that's what this little notation here is saying. All right, this little notation, if we remember this S letter means sum, so that means to add. So if we add all the probabilities from the first value in our sample space to the last value, see the n, that means the last one. So from the first to the last, if we add all the probabilities, they have to equal 1. Okay, so what does this mean? The sum of all the probabilities, and I mean all of them, from the first one to the last one, the sum of all the probabilities must equal 1. All right, and this last part, okay, this is a list of our probabilities. This describes the probability distribution of x, okay, so the thing that we are interested in. All right, so this first one here, this is the probability of the first outcome. Right, all the way, the second outcome, the third outcome, all the way up to the last possible outcome. And different random variables, discrete random variables, are going to have different numbers of possible outcomes. So, you know, if you're rolling a six-sided die, there would be 6 possible probabilities. But if you're rolling a 10-sided die, there would be 10 possible ones. So that's why we have this n, because it's for anything that we are making a probability distribution for. The probability of the last outcome. All right, moving on. How am I doing on time? Oh, I went over 5 minutes? I can't believe it. How did that happen? I practiced and it was less than 5 minutes. All right, the probability distribution of a discrete random variable can be given in table form, which we just did. It can be given in graphical form, but we're not really going to do that. And it can be given in function form. So we did that in class. I gave you some functions, and you use them to fill out the tables. Okay, so just like, you know, with an equation, you can represent an equation as a table, as a graph, or as a function. Same thing with probability distributions. Okay, you can write a function, make a table, or make a graph. All right, so here's an example. We're going to set up our probability distribution. A magazine store recorded the number of magazines purchased by its customers in 1 week, 23%. Okay, you can read that, blah, blah, blah. What is the random variable? So what are we talking about here? What is it that we could use for x? So the things that we could use for x are the number of magazines. So I had 1 magazine, I had 2 magazines, I had 3 magazines, 4 magazines, and 5 magazines. So what is the random variable? It's the number of magazines purchased. And if we make a table for that, I'm going to have my x, my probability of how many magazines, the probability of the number of magazines. So there could be 1 magazine, there could be 2 magazines, there could be 3 magazines, 4 or 5. There could be 1 through 5 magazines purchased. What's the probability of each one? There's 23%. Okay, we don't want to put percents into our table, so you're going to change them to decimals. So this would be 0.23, the next one would be 0.38, then 0.21, 0.13, and 0.05. Now, to make sure that you have an acceptable probability distribution, these probabilities must add to 1. They have to add to 1. If they don't, then this is not a legitimate probability distribution. It would mean that we're missing some data. And if it's more, if it goes over 1, that means that we somehow have some overlapping data that needs to be accounted for. Okay? So these must add to 1. So when you are setting up a probability distribution table, you always need to check, add them together, make sure that they do add to 1. So get out your calculator. After you've set up your probability distribution, make sure that you've checked it and that they add to 1. So I already did it ahead of time. There it is. I entered them all in, and it does equal 1. Okay, so make sure you're checking that. All right, so that is a probability distribution of a discrete random variable. Fancy words. Oh, have a good day. See you Friday.